Welcome to this video on Oracle Machine Learning for R. My name is Sherry LaMonica with Oracle Machine Learning Product Management. Today, we're going to learn about Oracle Machine Learning and specifically OMO for R, Oracle's interface to open source R integrated with Oracle Database. We'll begin with the enterprise machine learning pain points and give a brief overview of Oracle Machine Learning, and then we'll introduce OMO for R. So let's explore some of the pain points that enterprise data scientists and other data professionals experience in their machine learning projects. For example, you might hear it takes too long to get or load data, or that promoting models to production takes too long or is too complex. In other cases, there are concerns about data security, where the data is pulled into non-secure environments and maintained there, while others will mention scalability and performance as a major concern. This is where Oracle Machine Learning comes in. Oracle Machine Learning consists of a family of products supporting data science projects, and it focuses on interfaces for three popular languages, SQL, R, and Python. For interaction with Oracle Autonomous Database, we provide OML notebooks based on Apache Zeppelin with interpreters for SQL and Python, and we'll be adding R soon. We also have the Oracle Data Miner user interface, a SQL developer extension that enables users to create, schedule, and deploy analytical workflows through a drag and drop interface. Oracle Machine Learning for Spark also provides an R interface for machine learning in the big data environment with scalable parallelized algorithms. The Oracle Machine Learning AutoML UI is a code-free interface that automates model building, selection, and deployment. Finally, Oracle Machine Learning Services is a REST interface for model deployment and management, along with cognitive text analytics. Oracle Machine Learning for SQL actually supports OML for R. So we're briefly going to highlight some of the benefits since many of these also apply to the R interface. The in-database parallelized distributed algorithms keep data under database control, so there's no need to extract the data to separate analytical engines, which can be time-consuming and introduces issues for data security and storage. These algorithms are fast and scalable, and they enable batch and real-time scoring and provide explanatory prediction details so you can understand why an individual prediction is made. The in-database machine learning models are first-class objects in Oracle Database, so you can control access by granting and revoking permissions, audit user actions, and export and import machine learning models across databases. Open source tools like R, Python, and even proprietary tools normally require users to request data extracts from data sources and then load a flat file and then push the results back to the data repository. Some users can extract data programmatically through various connectivity packages. For example, on Oracle Database with R, this can be R Oracle, or with Python, CX Oracle. However, this is often problematic for larger data sets given internet bandwidth constraints and challenges with data access latency. Another consideration is that most R packages are single-threaded. Even if you have multiple processors available, scalability and performance will be limited when data is pulled from the database. There are also issues related to backup and recovery and security, enabling applications and dashboards to access production results, and this all adds up to unnecessary and undesirable complexity. Oracle Machine Learning empowers data scientists and other data professionals with open source R by leveraging the database as a high-performance computing environment. Database tables and views are accessed through R data.frame proxy objects with overloaded functionality that produces SQL transparently behind the scenes. The in-database parallelized machine learning algorithms are also exposed through a well-integrated R API. Data scientists and other R users can create user-defined functions and manage these in Oracle Database. R objects can also be stored and directly managed in Oracle Database, avoiding the need to manage flat files since deploying open source solutions can be challenging. User-defined R functions can be invoked from R or SQL. When OML for R is included in Autonomous Database later this year, a REST API will also be available. The functionality across OML for R is characterized by three functional areas. Using proxy objects, the transparency layer allows data scientists and data engineers to operate on database data using familiar R syntax, overloading select functions that construct SQL for in-database processing. The in-database algorithms are exposed through familiar interfaces, for example, using the R formula specification to indicate the target and predictors. User-defined R functions can be invoked to be run in R engines spawned and controlled by the database environment. Embedded R execution also enables data parallel and task parallel processing. For example, an open source machine learning model can be scaled to large volumes of data for making predictions by requesting that multiple engines respond to process chunks of data in parallel. OML also provides all the supporting infrastructure to simplify your application implementations. So how do we achieve this? OML for R introduces proxy objects that behave as R data frames, but they map to database tables and views. Here we show how the proxy data frame is a subclass of R's data frame class. Note that the structure of the R data frame, which contains the actual data, is really very different from the OML for R proxy object, which contains a query reference to the database table or view. This shows the data query that corresponds to the iris table in the database. For your reference, here's a mapping between the R data types and Oracle database. The OML for R mapping follows that of the R Oracle package. For example, if the database has a column of type date or timestamp, this gets mapped to R's POSIXCT data type. If an R data frame has a column of type POSIXCT or date, this gets written to the database as type timestamp, and others can be interpreted similarly. Here's a set of in-database algorithms supported in OML for R 151. Note that users can also take advantage of automatic data preparation, partition model ensembles, and integrated text mining, where you can identify a column as text and the tokens will be extracted automatically and combined with the structured content when building models and scoring data. Users can extend functionality and algorithms using open source R packages with embedded R execution, taking advantage of running user-defined R functions in data parallel and task parallel manner if desired. This example depicts in-database modeling using support vector machines with the R proxy data frame object mtcars. In the top example, we're building a regression model using SVM to predict car fuel efficiency in miles per gallon. The middle example shows a classification model, and the last example builds an anomaly detection model. We should note that the OML in-database algorithms automatically perform a select set of algorithm-specific data transformations known as Autodataprep. While Autodataprep is enabled by default, some data scientists may need full control over data preparation, and they can turn this off if desired, but it is enabled by default. Here's an example illustrating how OML for R embedded R execution allows us to build multiple models in parallel where data is partitioned by values from a particular column or set of columns. Perhaps we want to build one model per customer to identify patterns or to generate visualizations using an algorithm from an open source package. With the data accessible as a database table or view, we ask our data scientists to write an R script that builds a model for an individual customer ID. This is then wrapped as a user-defined function that is stored in the R script repository in the database. We can then invoke this function, which spawns the number of requested R engines in parallel, load the user-defined function, and pass one partition of data to each R engine to build models until all the data is processed. These resulting models, instead of being stored in flat files, can be stored in the database in what we refer to as the R data store. This is the R function invocation that allows us to create this scenario using the function ORA group apply. We pass in our customer data table and indicate that we want to partition on customer ID. Then we pass in the user-defined R function that takes two arguments, the data that will be passed automatically as an R data frame and the name of the data store where we want the resulting model to be stored. We build a model, which could also leverage one or more third-party packages, and use ORA.save to store the model in the data store. To complete the group apply function arguments, we pass in the string for the data store name, indicate we'll be connecting back to the database, and that we want this executed in parallel. We can also specify the number of parallel R engines we'd like. And this is just in a few lines of code to automate a very advanced parallel workflow. So why should you use Oracle Machine Learning for R? I'll highlight a few reasons. OMO for R empowers data scientists and other R users with powerful in-database machine learning. With the benefits of R leveraging Oracle Database as a high-performance compute engine, R users can perform scalable data exploration, data preparation, and machine learning, taking advantage of parallelism and model building and scoring optimizations while using familiar R syntax. The integration of Oracle Database with open source R environments makes it easy for users to deploy machine learning models and custom R scripts from SQL, simplifying data science projects and improving overall success as R users, deriving even more value from your Oracle Database data. Bringing the algorithms to the data has major advantages, and of course, Oracle Database and Oracle Autonomous Database themselves offer a long list of advantages for data management, security, performance, and scalability. For more information, check out these resources containing additional code examples, blogs, and documentation. Thank you very much for watching the video.